In this lesson, students will divide using three-digit dividends using the open area model. With this model, students will subtract out partial quotients, which are multiples of the divisor. In previous lessons, students have learned to divide with both one- and two-digit dividends using the open area model, and we will continue to model with three-digit dividends, or those that extend into the hundreds place value. Let's review the proper terms for the parts to a division problem. The quotient is the answer to a division problem, or it tells how many parts will belong to each group. The divisor tells the number of groups our total will be split into. And the dividend is the total amount we will be splitting or sharing amongst the groups. Let's begin with the following problem. The 5th and 6th grades were holding a fundraiser every Friday to sell beef jerky, and they earned $684. If they split the money equally between their 6 classes, how much will each class get? In the open area model, place 6 on the left side of the rectangle as the divisor to show the number of groups that the total will be split into. Then place the $684 on the far right to show the total or the dividend that we begin with. Remember from previous lessons that the divisor 6 is one factor that will multiply by the quotient or the other factor to make $684. Since we are working with three-digit dividends in this lesson, we will begin separating out chunks of 100. First, let's ask ourselves if we can make 6 groups of 100, and we can. We know that 6 times 100 equals 600, and 600 can be subtracted from $684. Let's write 100 at the top of the area model as the first partial quotient, and show that 6 sets of 100, or 600, by writing 600 on the inside of the area model. Now, let's subtract 600 from the dividend of 684, which leaves $84. There are no 100s left to place, so we will draw a vertical line to show the area model is finished with the 100 place value and move on to the tens. We know that 6 times 10 equals 60, so we can subtract 6 groups of 10 from the dividend. At the top of the area model, write 10 to show 10 as the next partial quotient, and write 60 in the area for the tens place to show the multiplication for 6 sets of 10 equals 60 on the inside. Then we will subtract out 60 from the dividend, which is 84 minus 60 equals 24. Now there are $24 left that we need to disperse. We may recognize that 24 is a multiple of 6 because we know that 6 times 4 equals 24, and so we can give each of the 6 groups $4. Let's record this action on the open area model by placing 4 at the top of the area model and 24 in the open rectangle. On the right side, let's subtract the 24 from the remaining $24, which leaves 0. Next, add together all of the partial quotients. 100 plus 10 plus 4 equals 114. Therefore, $684 divided by 6 equals $114 for each of the 6 classes. If we rethink the problem using multiplication to check our work, we can see the following. 6 times 100 equals 600, 6 times 10 is 60, and 6 times 4 is 24. Add the partial products together to get a sum of 684, proving that 6 times 114 as factors multiply together for the product of $684. Let's try another problem. Maya has 322 books. She wants to share them equally among her 3 bookshelves. How many books can be placed on each of the 3 shelves? Using the open area model, we will draw the rectangle and place 3 on the left side and the 322 books on the right. It is a 3-digit number, so let's first look for groups of 100 to place into the open area model. Each of the 3 groups will get 100, so write 100 at the top of the area model as the first partial quotient, with 3 times 100 equaling 300, so write 300 in the area model. Next, subtract 300 from 322, showing that each of the shelves will first get 100 books and be left with 22 books to still place on the 3 shelves. With 22 left, Draw a vertical line on the area model to show that we have completed sharing the hundreds and move on to the tens. There are 22 left to disperse among the 3 shelves. Knowing multiplication facts helps us to know that 3 groups of 7 equals 21, which is close to 22. Write the partial quotient of 7 on top of the area model and 21 inside the box. Next, we subtract 21 from the 22 books left. There is 1 book left over. We have partial quotients of 100 and of 7. When 21 is subtracted from the 22 books, there is a remainder of 1 book. When the books are placed on each of the 3 shelves, there will be 107 books on each shelf. The book cannot be split or left on the floor, so one of the 3 shelves will need to hold the additional book. When we go back to check our work, we notice that 322 divided by 3 is 107, with a remainder of 1 book. Since 3 times 100 is 300, and 3 times 7 is 21, and 300 plus 21 plus 1 remaining book is 322. We have proved that 3 and 107 are the factors that give the product of 321, and as the remaining 1 book is added in, we have the correct dividend. In this lesson, students learned to use the open area model to divide a 3-digit dividend by subtracting out multiple sets of the divisor as partial quotients. We did this by using an open area model and thinking about the context for the remainders.